Let's talk a little bit about encryption. Certain encryption methods involve public keys and private keys, which are the least secure method. If your private key can decrypt a message that a public key encrypts and vice versa, then those two by definition are related and therefore can be decrypted through good cryptanalysis. Other methods out there are standards. These standards have algorithms written and approved by the government. One of those methods is AES. AES type encryption encrypts blocks of data. It's otherwise known as cipher encryption. It'll encrypt 128 bits worth of data at one time, which means that you're not encrypting every single character, you're encrypting a group of characters. That method has been encoded. Companies such as Microsoft have used that method, and it's fairly secure, but the government has put their 2 cents in, and we know that there's a backdoor into that type of encryption. Our encryption is not published, and it's not standard. We'll go ahead and look at a little bit about what's included in our pad key. Our pad key has a series of numbers, 3 tables. Each table has 9,999,999,000 potential combinations. When we begin to encrypt the message, we'll look at various areas within this table to pull out a number to encrypt the letter A. That letter A, we will then add a unique number that represents an A to a portion of the number that's included in these keys, which makes that number different every time it occurs in the message. That letter A is never going to be repeated by any number, therefore no brute force method would be able to decrypt the message that we've encrypted with this process. We'll just go through the number of values in here, and as you can see, there's millions and millions and millions, and actually billions of different potential numbers that can represent every single A, as we saw in our encrypted text. When we look it up on the internet and we look at one-time pads, one-time pad is the only proven method of encryption that is impossible to decrypt through a brute force. We'll go ahead and encrypt the file now. Our example will be to encrypt a file that is all A's. So in this file you'll see that there's all A's within the file. In a lot of encryption software packages you will notice that all these A's are represented by the same number, and that same number would be repeated over and over. One form of cryptanalysis would be to analyze it and see if it looks like there are patterns that will be repeated. And you'll notice when we encrypt this and take a look at it with a hexadecimal editor that there won't be any information that you'll be able to understand. So let's go ahead and look at what's included in this file itself. Here is a representation of the characters within the file where no one of those characters are being repeated over and over and over, and therefore it is impossible to decrypt. Our next example will be to encrypt a picture. This will prove that our program can encrypt any file that can be stored on your computer. Whether it happens to be a picture, a text, foreign language, anything that you can store on your computer, we can encrypt. So we'll go ahead and select encrypt the file, and we're going to go ahead and select a picture of the Yahoo image that came off the internet. And this adds encryption numeric numbers to every single character within that file to uniquely represent what's in there. The file is now encrypted, and we'll take a look at what that looks like in our hexadecimal editor, and nothing in there indicates that this is a picture file. There's no JPG or any indication here indicating it's a file. Now let's go ahead and de-encrypt that file. When we decrypt the file, we have an option here to open this file in our default Windows program. So once it's decrypted, if it's a JPEG file, we'll open it in our picture editor. This goes ahead and reverse engineers and removes all the encryption, creates a JPEG file. Once we say copy it, in this case we'll overwrite it. Once it's overwritten and saved, it will log. This is a brief overview of our program. We have the option to encrypt text that we type in here. Once we type that text in, we'll just go ahead and encrypt it, give it a file name. That's your encrypted text. Or we can encrypt the file instead. As we saw previously, we can choose a picture file, a PDF file, any file that you have on your computer. In addition to the encryption, we can also add a new level by adding a password. So you would need a password in addition to the encryption. Once the file has been encrypted and stored, we can go ahead and decrypt the file. After the file has been decrypted, we have an option to open it up in your default viewer. Before you start using the program, you can generate a new pad key. This pad key is what makes the file that you're encrypting 100% secure. Only you will have this pad key, and this pad key is a series of random keys generated at the time that you receive the file. This pad key, as well as the encrypted message, will have to reside on the other person's computer with this program, and only you and they will be able to decrypt that once you have all. When you receive the program, you won't have a pad. Instead, you will need to generate that pad yourself by clicking on this area right here within your message. That pad will then be generated based on random numbers, and those random numbers are unique to your computer and your message only. That pad will need to be included as well as the message and this program to the other side for them to be able to decrypt it. That one-time pad needs to be sent to the other side securely, so it definitely should not be sent along with the message. Since this message is 100% secure, you now have the ability to send the encrypted message to the other party over the internet using unsecure type sites such as Gmail, Yahoo, because no one will ever be able to uncover what is inside that message. Now, although we do have a password option here, it's not really required. If you choose to add a password, then that is an additional level of security that no one would be able to read that file or even start the program without that. We do have to issue a word of caution here. Since this encrypted message is so secure, it requires the program, the message, and the pad key to be decrypted. If you generate a new pad key, it will overwrite the previous pad key. This message will never be decrypted again. We don't have any backdoors into this system. This is completely controlled by you.